Hello everyone. In the previous video we have discussed priority scheduling and round robin CPU scheduling. In this series the next CPU scheduling is multi-level queue scheduling. In multi-level queue scheduling the operating system partitions the ready queue into different separate queues. Most common separation is between the foreground processes and the background processes, or you can say interactive processes or batch processes, or one can say user defined processes or system processes. As these two type of processes have different type of response type requirements and hence they have different scheduling needs. Based on this, different scheduling algorithm can be applied to foreground processes and background processes. Generally, it is noted that interactive processes or user defined processes are most critical for the operating system. So every operating system consider these foreground processes or user defined processes as high priority processes. The basic idea between multi-level queue scheduling is that the scheduling must be done between the queues. There are different queues, or you can say the ready queue or the main memory is divided between different queues, and every queue can be implemented by different scheduling algorithm that we have already discussed. It may be first come first serve, it may be round robin, it may be priority scheduling, it may be shortest job first scheduling, or you can say the primitive type of short-term scheduling, that is shortest time remaining scheduling. This is how we can elaborate the multi-level queue scheduling. Here the ready queue is divided between different queues based on the different categorization of the processes that are created in the operating system. They may be user defined processes, batch processes, interactive editing processes, interactive processes, or background or system processes. Based on these different queues of ready queue, or this is the main memory, or you can say the ready queue is divided between different queues, and on every queue any CPU scheduling algorithm can be applied. Next CPU scheduling algorithm is multi-level feedback queue scheduling. That is somewhat different or somewhat equal to the multi-level queue scheduling, but only a feedback factor between the queue is added. This method or feedback allows us to upgrade or demote a particular process from one queue to another queue. Here is an example to understand this multi-level feedback queue scheduling more efficiently, that is this example. In this particular example we have three queues, or the ready queue is divided between three different queues, and I have already told you that on every queue any CPU scheduling algorithm can be applied by the operating system. Here on the first queue round robin is applied, on the second queue again the round robin is applied with different time quantum, and on the third queue first come first serve scheduling is applied. When any process comes into the ready queue, it is inserted into the first queue where the round robin of 8 quantum is applied. If it is of 8 quantum, CPU will be allocated to that particular process P1 for only 8 milliseconds. If it does not complete its total execution time, or it does not meet the total CPU burst time, after the completion of that 8 milliseconds, the CPU is preempted from this particular process P1 and shifted to the next process that comes into this queue, and that particular process P1 is now shifted or moved to the second queue of the ready queue. That is again a round robin of 16 time quantum is applied. The CPU is allocated for 16 millisecond for this particular process, and still if its execution is not complete with the CPU, or it remains CPU burst time for execution, this particular process is shifted to the third queue, that is first come first serve scheduling. If it goes to the first come first serve scheduling, and if CPU is allocated to this process in this particular queue, it will remain with the particular process till the final execution of that particular process as it is implemented in the first come first serve scheduling. And as the CPU is allocated with that particular process till final execution, this particular process will generate its output and release the resource and exit, or you can say terminate. This is how a multi-level feedback queue scheduling works. Thank you.